Wow, we're starting this day off with a math problem that talks about food, some of my favorites. Oh, right. So here we go. A hamburger at Joe's restaurant is made with 1/3 of a pound of meat. An order of 3 mini hamburgers at Joe's restaurant uses the same amount of meat. How much meat does each mini hamburger at Joe's restaurant have? Okay, we love to draw models here. So we're going to make 1/3 pounds of beef. I'm going to represent this with just a slab, and I'm going to cut this up into thirds because we have 1/3 pound of meat. So this one here, I'm going to gently shade it with my pencil to kind of represent 1/3. We love our models here. Oops, okay. More pressure. No pressure. Just teaching math here. Okay, so that's sort of shaded in. And so out of this 1/3, we're making 3 mini hamburgers. So we have to cut this third up, and actually the whole business up into thirds. 2 lines will give you thirds. So we've cut this whole hamburger up into thirds, which means that now if I have little mini hamburgers, I'm going to make 3 of them. 1, 2, 3. How much of each of these patties is going to go to each little mini burger? So this one would go here, and this one would go here, and this one would go here. Boom. Okay, so now if I look here and I'm seeing just this one patty, this one part of the 1/3, I see there's 1, 2, 3, 4, 5, 6, 7, 8, 9 parts to this 1/3. So this is 1/9 of a pound. Look at that. You didn't even have to do any math really. You're just using the model to help yourself. So how much does each mini burger use? Each of them equals 1/9. You're going to get 1/9 here. And there's the answer. Okay, let's talk about the math equation. Let's use the algorithm. So we need to know the total amount. The total amount is 1/3. And we divided this 1/3 into thirds. Okay. So because, we love the theme of food here, we have our this is the operation, the actual problem we're going to use to solve this is using division. So I'm taking 1/3, we're dividing it into 3 parts. However, when we're dividing fractions, remember, you can't just go and divide it. So let's help ourselves. You have a whole number here. You're going to put a 1 under it. This just helps you so that it will help you stabilize what has to happen. And then remember, you promised us KCF, not Kentucky Fried Chicken, because we're talking about burgers, but keep, change, and flip, kind of like a dance move here. We're going to keep, change, flip. So remember, you all promised us that you would always keep this fraction the same, 1/3. Then you're going to go to the next part. And because we're flipping this 1/3, we're doing the opposite, right? We're going to turn this fraction upside down. The 3 goes to the 1 and the 1 goes to the 3. And because we're flipping it, we're changing it. We're changing this whole operation. The opposite of dividing is multiplying. And now we do the opposite of 3/1, which becomes 1/3. And then you're able to multiply. 1 times 1 equals 1. 3 times 3 equals 9. 1/9 of a pound. Does our model match our equation? It sure does. We did a stupendous job here. So we're going to move this over to number 2. I love these volume. Okay, of course, we're going to use the model to help us solve how many unit cubes would be able to fill this object. So it gives us the side here, 1. It gives us the height of 5, and it gives us the length of 4. So we know that volume is going to equal length times width times height. And I'm going to just plug these numbers in here. The length is the longest part, which is 4. The width is 1 from here to here. So that means from here to here, that's 1. And you might see the measurements on different parts. So that's okay if you want to put it like that, units. And then the height is 5. So 1 and then 5. That's the number 1. We are the champions, my friends, because that's number 1. All right. Now you could just multiply these all together, and that's going to give you the volume, which we can do that right away. 4 times 1 is 4. 4 times 5 is 5. That gives us 20 units. And because we multiplied 3 dimensions, 1, 2, 3, you have to put a cube here. Cube it 3. That's telling us that you multiplied 3 dimensions, length times width times height. So make sure that's cubed. Do you see the answer down there? How many cubes could we fill that up with? Yes. So if you don't want to do the math, you could also do this. You could also put this here and put 1, 2, 3, 4, and you're making 5 layers because it's 5 high. 1, 2, 3, 4, 5. And then you're making this, you're going to chop it up 4 times. 1, 2, 3, 4. So then you have 4 units. So now if you wanted to, you could say 1, 2, 3, 4 for this layer. 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 So if I added these all up, 4 plus 4 plus 4 plus 4, it's also going to give you 20. So we showed you 2 ways to find the volume. Ooh, which one do you like best? Let us know here. 1 or 2, model or algorithm? M for model, A for algorithm. Let us know. All right, here we go. Number 3. Okay, don't get fast here. Do all the work. Show the work. 555. We're multiplying it by 11. And then remember how he's using the standard algorithm to help us here. We're going to multiply the ones to the ones to the tens, the ones to the hundreds. 5 times 1 is 5. 5 times 10 is 5. 5 times 100 is 5. Then that's the ones. We're going to do the tens next. And when we start solving for the tens, we're moving over. But before we do that, remember you put your placeholder, put your 0 here because this tells us we already multiplied the ones out. Now we're moving over here to the tens, and the tens to the ones, tens to the tens to the hundreds. So 5 times, it's going to be the same 5, 5, 5. And now you can add all these up. 5 plus 0 is 5. 5 plus 1 is 10. Carry over the 1. 5 plus 5 is 10 plus 1 is 11. Carry over the 1. You have 6. So 6,105. Boom. All right. Woo. Oh, putting some science in here because we love science. We love all things about science. You're using your critical thinking skills here, which you need for this problem. So we're going to read this here. It says this is the temperature and elevation data for 5 U.S. cities. So here's the map of the USA. Here's your cities. You have Detroit, Las Vegas, Oklahoma, San Diego, St. Louis. It tells us how much inches of rain they get, or sorry, the temperature, how much temperature each one is, the high and the low. And it tells us the elevation or the feet, how far up it is from the flat part of where the mountain starts and the ocean is. We use that to help us with elevation. The information that we have, right, the temperature and elevation data for 5 cities are Detroit's winters are colder than all the other 4 cities, and what best explains the difference. So we're going to go through each one and talk about what each one, the answers that you can choose here. Here you're saying Detroit is located farthest north. Okay, and so remember, you've been working on this in social studies. We're also going to bring in some social studies north, and this is south, and this is west, and this is east. And you're looking here and you're saying, San Diego. Yes, look at where Detroit is. Detroit is the farthest north, or the farthest one away from the equator. This would be Detroit. That would be the most north. Okay, so this one we're going to keep here. Detroit is largely flat. Does this information that it gave us here help us know if Detroit is largely flat or not? Even if it's true, this might be true, but this is not the information that we're asking you from. You have to take this answer from the information here. So this one we're going to delete. We don't know, right? So this is not part of the information that we're having to look to see. All right, is Detroit located on a coast? Well, if you remember, when we're talking about coast, we're talking about where the land meets the ocean. And if we remember here, this is your Atlantic Ocean, and this is your Pacific Ocean. Is Detroit lined up or butted up to an ocean? It's not. So Detroit's not located on a coast. And then here, Detroit is the lowest in elevation. So let's use our chart here. It says that Detroit has an elevation of 600, and then Las Vegas has one of 2,000, Oklahoma City 1,230, San Diego has 40, and then St. Louis equals 465. So just by looking here, we know that San Diego actually has the lowest. So boop, we are not using that information. You have your answer. We are scientists and mathematicians. Great job.